Okay, so we're going to do section 3.1 where we talk about graphing linear functions. And the first form that we're going to introduce in this section, even though it's not actually really in this section, is going to be slope-intercept form. So we're going to do y equals mx through and do the table method at the beginning, and I just feel like you're beyond that, so I don't really show you the table method. We'll talk about table method when we get into a little bit more difficult functions where it's actually more useful. But in this case, y equals mx plus b. M is your slope, and then your y-intercept is always a b. And the reason that that's important is because whenever we get ready to graph, we're always going to start with a point. So if we know the slope and the intercept, the only one that's a point is this, the y-intercept. And when we graph the y-intercept, we're always going to start at the origin, and then we go left or right first, and then up or down based on the two coordinates. That's different than when we do the slope, because with our slope is a fraction, and it's telling us a ratio at which the graph is climbing, or if it's going down, then the rate at which it's falling. So that slope is going to be given by going up or down first and then moving left to right. So that is in a different order than when we do points. So when something is in parentheses, an ordered pair, you always start at the origin. When we start with slope, we're going to start at a point on the line. All right, and then if we're going to graph using intercepts, this is where we plug in 0 for the opposite variable. Intercept, I put a 0 in for x. You can see that actually is showing up in your slope-intercept form. And if we want to know the x-intercept, then I would plug in a 0 for y. Now, the one thing is you can always plug in any number. And because a line is going to go left to right and across the entire graph, okay, the only kind that don't have a domain of negative infinity to infinity for a line are when you have a vertical line, and that's not a function. So we're going to talk more about that as we move into the later chapters. But right now, the thing I want you to understand is that you can plug in any value for x and get a value for y. So if we have a slope-intercept form that doesn't look pretty because maybe it has a fraction for the y-intercept, then you could just plug in numbers into the original equation and find a graph that way. That's when that table method is going to come in handy. But the vast majority of the time, we give you a nice y-intercept, so we like to put the equation, in slope-intercept form. All right, so if we take a look at these, you notice if I rearrange the order here, we have y equals before the constant. And now that that is in that form, we can tell that the slope is negative is going to be 0, comma, and that's the b that goes there. Now, when we get ready to graph this, let's set up our graph with x and y. Zoomed in version 10 by 10. All right, so I'm always going to start with a point. So if I look at this graph, the only point that I know right now is the y-intercept. Left or right, 0, and then up. So that is my y-intercept. And then when I use my slope, I'm going to move to the slope, which is the fraction, and that's going to tell me how to get to my next point. So from the red point that I drew, I'm going to go down 3, so 1, 2, 3, and then over to the right 1. Now I know that along the way you probably heard that your top number tells you up or down, and then your bottom number of the fraction tells you left or right. And some of your teachers along the way may have said that if it's a negative on the bottom, then you go down, and if it's a negative on the top, blah, blah, blah. So I'm going to keep it simple. So remember I said I like to put my negative sign at the top. And so the way that it works is when I'm looking at slope, okay, the top tells you up or down, and then the bottom is always going to tell you to the right. And the way that I tell you this is that the top you will know because if there's a negative, we're going to have it at the top, and a negative would mean to go down, a positive would mean to go up, and then you're always going to go to the right. And I always say because Swanson is always right. Now, I'm really not that egotistical. It's just a simple way for you to remember it because I will actually see people during the test laugh to themselves when they think about that, and if it makes you do it the right way, then it makes me happy. So we're going to go up if it's positive, down if it's negative, always to the right. So let's take a look at the next graph. If we look at this one, we have it already in slope-intercept form because I have y by itself, and it's in that mx plus b form. So my m is 1 over 6, that's the slope. And then my y-intercept in this case, so I can set up my graph. So x, 1, 2, is that I always go at least one more in every direction that I'm going to need. So I'm going to go starting from the origin. Now I put a little dot here just so you can see that that's where I'm starting, if you can see that little orange dot on the graph. But there's no dot there in reality. It's just to let you know where I'm pointing. So we're going to start at the origin, and we're going to go left or right 0, and then down 2. So 1, 2, and I put a point. And I'm getting this again because of my y-intercept that I see over here. So you can see from that orange dot, I'm going to go up 1 because it's positive, and then right 1, 2, 3, 4, 5, 6. And I draw a line with arrows on the ends all the way to, you notice there are arrows on the ends of my axes, on the ends of my lines, and it goes all the way to the edge of the graph. I didn't draw my line and have it stop halfway through the graph. I drew it all the way to the edge. Same thing here. You notice all the arrows on the ends, and my orange line went all the way to the edge of the green. All right, let's do it again. So this time they want you to reduce the equation first if possible. You don't have y-intercept, so that's what we're going to start with. So if we're going to graph by using the x and y intercept, that means I have to plug in zeros. Anytime you want intercepts is always going to be linear, quadratic, anything. You're always going to plug in a 0. So let's start with a 0 for x. 3 times 0 minus 5y is equal to 15, negative 3. But the important question is, y doesn't always equal negative 3. It only equals negative 3 when x is 0. So this is the point, 0, negative 3. And because it has an actual value in the y position, it's a y-intercept. So then we're going to repeat that. Now we're going to put in a 0 for our y. So 3x minus 5 times 0 is equal to 15. Obviously, the second term there is going to disappear, so we get 3x 5. It only equals 0. Graph this. 1, 2, 3, 4 points. So we start at the order. Every point that I plug in here true. All right, if we take a look at the next one. Let's do that. So if we start 8 times negative 48, negative y equals, it's x equals 0. X plus, if we have 6, and I plugged in a 0 for the y. So now if we're going to graph them, 5, I got to extend that a little bit. I didn't make it quite long. Negative 4, 4. It's going to be 6 to the left and all the way to the edge of my graph. Next ones, you notice that this line looks weird, or the equation looks weird, I should say. And the reason that the equation looks weird is the same reason that it looked weird in Chapter 2. It is missing a variable. And we knew when it was missing a variable that something weird happened with our answer. So when the equation is missing a variable, again, something weird happens with our line. If we are missing a variable, it will either be vertical, be a regular line, horizontal if I can spell it. It's not going to be a regular line that goes at an angle. It will either be vertical or horizontal. So there's no real work to do. So I'm going to start off by 2, 3, 1, 1, 2. It says x equals 0. So that means on the x-axis, I'm going to go to, or excuse me, not x equals 0. It says x equals 5. So on the x-axis, I'm going to go to the value of 5 and put a point. And if I wanted to cut the x-axis, I wouldn't want to draw along the x-axis. I want to cut it. So I'm going to draw my line the x-axis, and I don't want to do that. And what this means, if you look at these, if you pick a point along here, which is what you have to do on your My Math Lab in order to draw it, you need to pick any point above or below so that you have 2 points to draw. But any point that you choose, for example, let's go with that one. This is the point 5, 1, and the point that we had is 5, 0, and up here would be 5, would be 5. That's why this line is x equals 5. Okay, so now we're going to do it again, but it says y equals -3. So I can write vertical, by the way, if I'm describing it. By itself is missing. Go to the point 0, -3. So in other words, the value of -3 on the y-axis. And if I wanted to cut the y-axis, I would have to draw my line horizontally. Are unique lines, the ones that are either vertical or horizontal. Right now is a decimal instead of a fraction. And if you know what that fraction is, then you're good to go. This is a very basic one, so you probably do know. But in case you don't, all right, right now we have 0.5 over 1. And we don't like having a decimal inside a fraction. So I'm going to move the decimal place over 1 position. And if you remember, moving a decimal 1 position means that you're multiplying by 10. So for every position I move it, I have to add a 0. So I'm going to move it 1 and add a 0. So in other words, this is 5 over 10, which we know reduces to 1/2. So I have y equals, and then we can graph it. 1, 2, 1. When I look at my equation, I have a slope of -1/2. And then my y-intercept is going to be 0, 4. So I'm going to go ahead and start off with this point. It's in parentheses, so that's why I start at the origin. I go over 0 and up 1, 2, 3, 4, and I put a point. 1, and then to the right 2. And the reason I go down 1 is because the slope is negative, and I go to the right 2, and then there's my graph. Now my graph might not be perfect, but that's okay. I have the right points drawn here. It's not all perfectly to scale, but you can see that I don't have huge gaps and then little tiny gaps. I try to keep it looking as good as possible. All right, so when we get to the next one, we're going to try that trick again. So you notice I have the number 1.25. So right now I have 1.25 over 1. And if I look at this, I'm going to use a different color so we can see it a little better. I need to move the decimal 2 places, so I'm going to add 2 zeros. So that means I have the number 125 over 100. And I know 25 goes into both of those, because if I have quarters, 125 means that I have 5 quarters, and 100 means that I have 4 quarters, and that doesn't reduce anymore. So y equals 5/4 x minus 7. So again, my slope is 5 over 4, and my y-intercept is 0, -7. So we're always going to start with the y-intercept because that's our only point that we know right now on the graph. And then, let's see here, 1, 2, 3. So we go to 0, -7. So starting at the origin, I go left or right 0, and then down 1, 2. From that purple point I just drew, we're going to go up 5, up because it's positive. So 1, 2, 3, 4, 5. And then the bottom number is 4, and we always go to the right for the bottom number because Swanson's always right. So 1, 2, 3, 4. And then I can draw my line. Arrows on the end all the way to the edge of the graph. All right, let's finish it up. So again, it says simplify. Well, we know that we wanted it to be in y equals mx plus b. So to be in y equals mx plus b because that would be slope-intercept form. So for intercepts, all we want to do is get it looking like it did before, which is where I had the x's and y's together. So if I do so, I can add 3 and add 3. All right. So that gives me 6y equals 2x All right, well, when I look at this, that definitely looks different, and that's because it doesn't have that third term. So there's really some different ways that you can approach this. You could say, all right, I'm going to plug in 0. So if I plug in 0, all right, 6 times 0 equals 2x. That means 0 equals 2x. And if I divide by 2, I get x equals 0. Well, when does x equal 0? It's when I plugged in 0 for y. Now you notice this problem is unique because it gives you both the same x and y intercept, which happens to be the origin. That's the only time that's going to happen. So if I tried to do it again, I'm going to get the same point. So when we get ready to graph, we need to know 2 points. So there's a couple different ways that you can do this. But you notice right here, I almost have it in slope-intercept form. So if we have 6y equals 2x, I could simply divide by 6, and that would give me y equals 2 over 6x, and 2 over 6 will reduce to 1/3 x. Now you notice that's in slope-intercept form, so I know my slope is 1/3, and I know that my y-intercept is going to be 0, 0. All right. And the reason I have to do that is I always have to have 2 points in order to be able to graph. So this way I'm going to use the slope to get another point. Or I could plug in random numbers until I got one that worked nicely. And I will tell you, if you look at the coefficients, 6 or 2, those are good options to start with plugging in. So I'm just choosing to look at it in slope-intercept form to get that second point, because I do have to have 2 in order to be able to graph it. So if I take a look, I have 0, 0. And then from that point, since it's a positive 1/3, I would go up 1 and then always to the right. So we're going to go right 3. So that's where my second point would land. The little dots that I'm making as I count are not going to actually go on the graph. It's just to show you in the video where you're looking. All right, and if we look at the last one, as soon as I look at this equation, I know that there's no x in it. So right away, I'm thinking in my head, it's either vertical or horizontal. So we need to get the y by itself. Whatever variable is there needs to be alone. So 4y equals -20. And if we divide by 4, I get y equals -5. Now you notice all the other times I asked, when does y equal -5? But back up here, we didn't plug anything in. So it's not that it only equals -5 when x equals a certain number. Y always equals -5. And that is a weird looking line then. So when we get ready to graph it, I'm going to put a point at -5 on the y-axis as soon as I have it all set up here. And remember, we want everything labeled nice and neat. 1, 2, 3, 4, 5, 6. So I'm going to put a point at -5. And if I wanted to slice the y-axis, I'm going to draw my line horizontally. And that is what I expected to get when I started the problem, so I feel good. And again, the reason that I get this horizontal line, if we are describing it, is because a variable is missing. So that same theme occurs. When a variable disappears, that's how you know that something weird is going to happen. So that takes care of 3.1.